This is a continuation of section 3.1, so it's 3.1B, significant figures. Whenever you take a measurement, there's always some error. So the last digit that you measure is always considered to be estimated. So, need a T in there. The last digit is estimated, so all the other ones are good. But the very last one, you should always estimate one place beyond what your equipment is marked in. So for instance, if you're measuring something and you have a ruler that is marked in centimeters, you should be able to estimate to the nearest tenth of a centimeter in between that ruler. So for instance, let's make it even easier. Let's say that this is my ruler and it's measured in inches. Each of these is an inch. And I'm measuring something that is that long. Well, I shouldn't say that that is 2 inches long because I can tell it's between 2 and 3. So there's 1, 2, 3. So what I really should do is estimate. Well, that doesn't look like it's quite half. Looks like maybe it could be a 3 or a 4. So I'm going to say that is 2.3 inches. So my last digit there, this 3, is an estimate, and it has some error because it could have been a 4. So it could be one or the other. And so that is why we worry about significant figures when it comes to chemistry. So whenever we make a measurement, you always need to report it to the correct number of significant figures. Or a lot of times you'll hear me call them significant digits because that's what they were. That's what I was taught they were. So anyway, significant figures, significant digits, same thing. But we always want to write them all out because it becomes really important, especially when we start doing calculations like multiplying, dividing, adding, subtracting. It's important that we have those particular things. And there are some rules that work for significant digits. Rule number 1. All non-zero digits are significant. In other words, if I have the number 12, there's no zeros, everything is significant. So there are 2 significant digits. If I have the number 247, no zeros, everything is significant, there's 3. This is the easy rule. This rule covers the numbers 1 through 9. Every other rule we have covers the number 0. So the numbers 1 through 9 are simple. 0 is the tricky number that you always have to figure out. Well, what's this? How significant is that? What is this? And that's what we're going to do here right now. Rule number 2. Zeros between 2 significant figures are significant. So we said that the 1 and the 2, when we had the number 12, that was significant. If I had the number 102, this one is in between the 1 and the 2. Both of those are significant. Therefore, there are 3 significant digits. If I have the number 409, 3 significant digits. If I have the number 221064, well, we know all of these numbers, all the digits 1 through 9, significant. So there's 5. The zeros in between. This one's significant. This one's significant. Therefore, this one is. Therefore, this has 6 significant digits. So anytime a 0 is in between anything that's already significant, even if that, well, let's just leave it at that. Anything that's already significant, then the 0 is going to be significant. Okay, rule number 3. Preceding zeros are not significant. In other words, if I have a number like this, 0.0021, I consider these zeros up until the first digit 1 through 9 to be preceding. Therefore, they are not significant. So not, that means there are 2 significant digits. A number like this, 0.015, not significant, it's preceding, significant, 2 significant digits. Okay. take a look at this one. What if I had 0.00108? How many significant digits? All right, remember this. Preceding, not significant, never significant. Okay, never. This one is the only other one we got to worry about. But go back to rule 2. Zeros between two significant figures are significant. Since that's significant, this one has 3 significant figures. Rule number 4. Zeros at the end and to the right of the decimal point are significant. In other words, if I have the number 4.0, this one is at the end, and it is to the right of the decimal place. That's different than this one, 40. This one is at the end, but it's to the left of the decimal place. So here, that's different. This one is significant. So numbers at the end, I sometimes call those trailing zeros, are significant after the decimal point. Trailing zeros after the decimal point are significant. So take a look at this. 5.100. All right, we know this. We know 5 and 1. Those are easy. We're looking at the zeros. Are they trailing zeros? Yes. Are they after the decimal point or to the right of the decimal point? Yes. Therefore, they are significant. This means there are 4 significant figures in this one. Let's do another one. Let me see if I can add a page in just so we can write. All right, let's say that I have 4, 1.1010. All right, so take a look and see how many significant digits would I have. Easy thing, we know those are. Next thing, we know anything that's in between those are, so we know that one is. And the last one is this one. Well, that's a trailing zero after the decimal, so everything I wrote is significant. Therefore, 6 significant digits. Okay, try another one. What if I had 501.0? Take a look. How many significant digits do I have? Easy, easy. In between, definitely. After the decimal point, to the right of the decimal point, trailing zero, yes. So 4 significant digits in this one. Okay, let's go on to the next rule. Rule number 5. Zeros at the end, but to the left of the decimal point, are not significant if the only purpose that they have is to hold place. In other words, here's what I'm talking about by holding place. This number, 400, is not the same as this number, 4. But I need to indicate that it is 400. I need those zeros in there for place value. They are to the left of the decimal point. Here's my decimal point. They're to the left. So they're trailing zeros to the left of the decimal point. There's no significant digits after them. Therefore, these are not significant. So this one only has 1 significant digit on this problem. So zeros at the end, but to the left of the decimal place, so not significant. Now let's take a look at another example. Let's say that I have 5,100. Significant, significant. These guys come before the decimal place. They're only there to hold place value. Therefore, they are not significant. Now notice what would happen if I do this. If I put that in, is this one significant? Now think about it. It is a trailing zero to the right of the decimal place. At the end and to the right. So yes, this one's significant. Now these come into rule number 2. Zeros between two significants are. Therefore, if I put this 0 in here, they all become significant. That's 5. Think about it this way. I would not write this down. I would not write 0.0 down if I had not measured it that accurately. It might just happen to have come out to exactly 5,100, but I measured it to the nearest tenth. Therefore, that one is important. That's a whole lot different than if my ruler is marked by the nearest 100. So it's got to be included, and all these in between then become significant in that case. Here's one other thing that's important to keep in mind. Counting numbers. So if I'm counting the number of people in the room, that I'm going to get that exact. There's no measurement involved in this. I'm counting. Or defined quantities. They have infinite number of significant figures. What do we mean by defined quantities? Well, this is a defined quantity. If I say 100 centimeters equals 1 meter, that is defined, that is exact. Therefore, whenever I use that type of thing in maybe a conversion factor, that would not change. That's going to have an infinite number. I can count as many as I need to. What is going to matter is I'm probably multiplying it by another number, and that's going to make a difference as to what it is. All right, let's do a few problems here. And what I would suggest that you do is go ahead and stop the video and then write these answers down. So I'm just going to give you some different things. Let's say that I have all right, do those problems, figure out how many significant digits there are. When you got the answer done, come back. Don't just watch me do it. You won't learn anything doing it that way. Okay, for this one, all of these are significant. This is a trailing zero. It comes before. I'm going to follow my pattern. I shouldn't do that. It comes before the decimal point. Here's my decimal point. Therefore, trailing zeros that come before the decimal point are not significant. So this one has 2. Yes, yes, yes. Anything in between, yes. Therefore, 4. Preceding zeros are never. That's kind of a hard and fast rule. Anything at the beginning. Any zeros at the beginning, never count. Yes. Trailing zeros after decimal, yes. So once again, I kind of did this. I'll be doing it this way. Try not to. Okay. Trailing zeros after decimal, yes. So this would be no, 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 yes, yes, 2. Okay, easy. In between, yes. Trailing after the decimal point, yes. So 6. Easy. Trailing zeros but before the decimal point, no. Don't count. 1. Preceding, no. Whoops, get out of here. No, no, yes. Trailing zeros after decimal point, yes. 3. Hopefully you did that right.